All right, so this week we are going to cover the enum module in the standard library. I'm going to post the documentation link into the chat if you would like to follow along. Okay, so first of all, we probably need to talk about what an enumeration is. So most of my experience dealing with enumerations comes from my experience programming in C and C++. And in those languages, an enumeration is just a convenient way of automatically assigning, creating integer constants in order automatically. And so you would say, I want an enum. The enum is going to be like colors or something like that. And then you would just give names to your various colors in your enumeration. So you go like black, white, red, green, blue, yellow, whatever. And the compiler would automatically associate a integer value with those names. Now, there's some typing issues with that. An enum isn't really supposed to be in the if you want to talk about enums properly, you say, well, they're not really integers, but C and C++, enums were a type of integer as a convenience. And so you could do things like you could index arrays with them. You could do things like you could have you could, again, going back to our color example, you could have black, white, red, green, blue, yellow, and then like your last enum would be number of colors, and then you would use that to define the size of your array. And so then if you added more colors in, your array would automatically get bigger next time you recompiled it, and it would automatically it would automatically change that last value as you added in values before it. And so it was nice and convenient as a way to give values in an array a name. But there's a little bit more to what you can do with enums. So technically, an enum is not an integer. An enum is a set of unique constant values. And so what this module seeks to do is to help us to come up with a better way of dealing with this pattern right here. So you might, before the enum module, you might do something like this. Color, let's say black equals 0. And I'm just going to copy and paste this a few times. Okay. So then you would do something like white equals 1. Blue equals 2. And you do this sort of thing. And I was like, okay, so what if we needed to add more? Well, we just go ahead and add more names, and we just assign them different values. Let's see. Either James or Shant is making noise on their microphone. Okay, I think that's better. Thank you. Stuff like this. And then you would say, if you're doing this in Python, then you might say like number colors or something like that. And this becomes problematic because if you did something like this, then what happens if you add more colors in? Then you have to go and make sure that you change the number of colors. And there's problems with that. So in order to, and the thing is like in terms of an enumeration, you don't actually have to assign these numbers. So this could be like black and white, stuff like that. W-H-I-T-E. And so you could approach it like this as well, but this is inconvenient and it's error prone. And so an enumeration gives you a way of building these kinds of constant values conveniently, and gives you certain properties that you can to make sure that you don't use them improperly, and that you can take advantage of some of the same stuff that you would do in C. So this module has also been backported to Python 2. I know that in Voltron, I believe we backported. There's at least one service agent that we've used the backport of the enum module to do some work with. So I'm going to take this and I'm going to replace this with an enum. So we do from enum import capital E enum. Okay, and then so that gives us the enum class. Now for the most part, this is like a normal class. There are a few methods that it creates for us automatically with the meta class, so it's not the same thing as a normal class. And it's not just doing it with a base class, it actually has to build the methods because they behave uniquely depending on some of the other stuff that you do. So we're going to go class color, colors, color, and then we're going to inherit from enum. And then we can go ahead and we can list out some colors that we want to use. So there's a couple of ways that we can do this. We can explicitly declare our name, which we have to do, and then we need to assign it a value. So we can do red equals 1, green equals 2, and so on. I'm just going to complete the example here. And so what that does is that gives us an enumeration with 3 values in it. And okay, so how do we use this thing? So let's look at some examples here. So I'm going to go ahead and make sure I save that, and then do Python, run our. Let's see, I do not want to run that. I want to run Python 3. There we go. And we're going to go ahead and import example 1. And let's see. Actually, let's do from 1 import color. So now we have a color enum. And one of the things that so when we declare these values, it actually automatically declares instances of the color class with different values for each enumeration, and then they become values in the color namespace. So we can do color dot red, and so that gives us back the color red enumeration and gives us the value. So if we represent it as a string, it's going to say color.red. So now we have our color enumeration that we can use. We can check for type. Let's see. And it's a type of the enumeration color. We can, of course, do the is instance check. Read green. Of course, that comes back true. And then within the the red enumeration, we've got different values that we can check and use in different cases. So red, and we can get the name. So that gives us red. And then we can also get the value. Now, even though I've assigned this a value of 1, this doesn't make red an integer. Red is still an enumeration. So if I did something like color, let's do this, color red equals 1, that's going to be false because we're comparing different types. I could do this, but that's usually not how you go about using enumerations, because most of the time the enumeration, if you're using enumerations properly, most of the time you don't actually care what the value is. And so that brings us to questions like, well, you made us assign a value, so how do we get out of having to actually assign the values ourselves? So we can get auto, and then we can call the auto method instead of assigning the values explicitly. Okay. So in this case, auto starts with the number 1 and will increment the values automatically. So as we add more, it just assigns them automatically, and then we don't have to worry about what values our actual enumerations correspond to. Oh, I think I hear a child crying. I might have to take a break here in a minute. So let's see. So we can also iterate through our enumeration. Like that. And enumerations are considered unordered, so you can't compare one enumeration to the other. But when you iterate over them, well, let's see. They are unordered in that you cannot compare them. So you can't say this one, ask if this one's greater than another one. So if we did like color dot red greater than color dot green, we can't do those types of comparisons. So there's not an implied order value. You can't like sort them by their value because they're considered to be unorderable. It is possible to add that in, and there's an example in the documentation if you're really worried about that. And there's actually another type of enumeration where you can get that kind of behavior. So what do we want? So then enumerations are also hashable, so you can use them as a dictionary key. So let's see, colors equals something like that. And then we do colors, and let's see, color dot blue. And let's see, something silly like that. And so now we can see that our enumeration for color maps to our string. So we can use enumerations in a lot of the same places that we would use any other constant because they're hashable. You can assign, of course, then you can assign a value. You can assign a variable to to an enumeration. So we can do something like color equals color dot green, like that. And then that's our enumeration instance. You cannot duplicate names. So if I did something like this, that's an error when it tries to create the instance of the enumeration. But you can reuse values. So I could do yes. And then I could assign that to red. And that would work. That should work just fine. Yep. Okay. So now if I did You see now that alias red is actually an alternative name for red. And if I was manually putting in values, and I said red is 1, green is 2, blue is 3, and alias red is 1, it should do the same thing as it's doing here. So we can also look up enumerations by their value. So we can do something like this. We can call 2, and that'll give us back the enumeration associated with that value. And then if we don't know the name of the enumeration ahead of time, but we need to figure it out programmatically later, we can use the item access interface like this and get back the enumeration associated with it. Okay. So that's the high level stuff. Now, if we want to ensure unique values in our enumeration, we can use the unique decorator. So we can do at unique like that. And this will enforce unique values for each enumeration. So if we quit out and go back in, we're going to get a value error because we've attempted to assign two different enumerations to the same value. Okay. We discussed automatic values. There is a way that you can we'll leave this outside the scope of the tutorial. There is a way that you can override the behavior of auto. Say if you wanted it to start from 0, or if you wanted it to use some other mechanism for generating the names, then there's a method in your enumeration that you can override, and it will change the way that auto behaves. Let's see, we've already talked about iteration. Oh, also, if we iterate over, so let's go ahead and remove unique. If we iterate over a, actually, let's just do this. List color. There. You'll notice that it leaves out the alias for red. So if you iterate over a set of enumerations and you've got duplicates, it skips the duplicates. Okay, so traditionally, if you're going to do comparisons with enumerations, because they're singletons, you use the is operator rather than equality. So we would do color dot red is color dot alias red, like that. And if you wanted to do like a if you wanted to do not comparison, then you would use is not. Okay. Let's see. You can use equality. You can use equality operators. Those do work as expected, even though you should use is. Another thing is if you have two different enumerations defined and their values happen to be the same, they do not compare as equal because they are considered different types. Also, like I said, you can't do a comparison to the value directly unless you explicitly look up the value member of the enumeration. Okay. Let's see. I'm going to skip down to an int enumeration. So there's a couple of special types of enumerations. So we'll look at the int, let's see, capital I, int enum. So the int enum is a special form of an enumeration where can be used interchangeably with the enumerations can be used interchangeably with integers. This is not recommended unless you are doing something where you're doing something that involves interoperability. So you have a specification that has like flag values, and actually there's a special flag enumeration too, which we'll talk about here in a second. But say that you've got um, an array of data coming in over the wire, and you need to and there's names associated with different elements in that array. You need to be able to use that or you need to refer to something by its name, but what you're really doing is you're supplying a name to an integer which you're going to use in like the implementation of a wire protocol or something like that. Then you would use int enum, and in that case it enforces that all the values are integers, but the int enum also inherits from integer. So it is an integer that has the enum behaviors built on top of it. So now you can do actual comparisons with integers, and it will work the way you expect. So let's do that here. Quit. Okay. So let's say color red equals 1. That's true. Now, because the individual enumerations are now integers. And like I say, this is a convenience for interoperability and implementing wire protocols and stuff like that. Typically, it is not something that you would normally use. Now, this is one, again, if we're going to talk about implementing wire protocols, this is one that's particularly interesting. So there's also there's int enum, there's also int flag. And so this, I'll just show you what this does because it's easier to show than it is to explain. So this takes, this is also an integer-based enum, but instead the integers can be used as bit flags. So one of the things that you can do with any of the flag enums is that you can OR them together, and so you can create like sets of flags. So you can have a set of enumerations. So in this case, I could do something like, so you'll notice my auto assignment didn't go 1, 2, 3, it went 1, 2, 4. So it's each value that it auto assigns is a power of 2. Which, if you're going to pack all of these values into a single integer to send over the wire, this is really convenient. So, so then we can also, in addition to just having values associated with them, we can use our bitwise operators to put them together. So we can do something like this. And that gives us the new value, which is 3. If we're doing integer flags, that's correct. And then it shows it as, yes, this is green and red put together. And in fact, we could do something like this. Yellow. And we're going to say that this is a additive, subtractive color scheme. I forget which. So we'll say blue and green. So we can do blue, green, and this totally works. So now yellow is defined as the set of flags green and blue together. So then if we decide to, so let's go ahead and save this and re-import it. So if we, and if we list this guy, it says that now yellow is 6. So we've given an alias, basically we've given an alias to a pair of flags 2 and 4. So if we take green and blue, green, color blue, it returns yellow. So that's the kind of stuff that you can do with this. Let's see. There is also a non-integer flag, which again supports the different bitwise operators, but it is not built on top of integers, so you can't use it like integer, but you still get the combinations of values. So we could still do this, and yellow would still evaluate to 6. All right. Let's see. That's all I've got. Everything else is kind of in the weeds. But are there any questions? I guess I should ask if Brandon has anything to add.
Yeah, so just one of the cool things that you can do with this is you can actually look up the members. So like test for membership of an enum by using the the indexing syntax.
Like this? Let's see. Is that what you're talking about?
Yeah.
Okay.
And then you can also construct. There's things you can do with the constructor too. Anyways, what's cool about this is I actually use enums to validate inputs that I'm receiving. Right. So if I know a value can take only a certain number of values, you can create an enum, and then you can use the enum as the
as your validator.
Yeah. So you can use it with click, for instance, when you have like a set of choices that you can take in.
Mm-hmm. Yeah, and I'm using flags here, so flags isn't a good example. If you pass it a value that doesn't exist, it says, okay, here's all of the things that exist in what you've given me. So 12 is not a good example. Let's do 16. Yeah, so there's none of the other flags are within that value. But if we were doing like a normal enumeration, and I tried to do color. In fact, let's do that real quick. So, and let me make sure. Just if so, this is kind of what you're talking about here. If I'm understanding you correctly. So we could do color, and then 4, and it'll say 4 is not a valid color. But if we did 2 or 3, we'd say, yeah, blue is in there. So that's the type of validation you're talking about, right?
Yeah, absolutely. And typically I'm using it with strings. So that's the other nice thing about the enums here in Python, right? Is they don't have to be integers. The values don't have to be integers. They can be strings or really whatever you want them to be.
Yeah. And in fact, there is, I think they show a method for automatically assigning the name of the enum, the string form of the name to its value in here in the code. I'm trying to remember where I saw that. I can't remember if it was something that was just built in or you had to roll it up yourself. But yeah.
Yeah. The other great thing that the other thing that enums are great for is type annotations.
Can you elaborate
So
on that?
if you're using MyPy to validate inputs to a function, and those should be limited to a certain value or an enumeration, then you can use the the color as the type in your type annotation, and then MyPy can validate what's coming in.
Oh, so if they passed in a 4 instead of a 3, it would say, this is this is not going to work, my pi would tell you it wasn't going to work, for
Well, if you
example.
passed in just a number, typically it's not going to work unless you're using like in
In
int.
enum,
Yeah, but if you're just using a standard enum, it expects an enum member. So you'd
Mm-hmm.
have to do color dot red, color dot green.
Mm-hmm. Okay.
And if it doesn't see those, then it'll give, you print out a type error.
Yeah. Cool. All right. Are there any other questions? I noticed a bunch of people started to bail when I got into the weeds. um, are there any questions from anyone who's left? All right. Well, then we'll call it a meeting. Thanks for your help, Brandon. Um, I hope to gain a little bit of more experience with enumerations going forward, because they weren't in Python 2, and so I never think to use them. I'm not as experienced in 3 as I'd like to be, so we're getting there. But yeah, if there aren't any questions, we'll call it a meeting. Thanks for coming.
Thanks, Kyle.
Thanks, Brandon. You're welcome, Casey.